right, let's just jump right in. Have you ever been outside at night, looking up at all those stars, and had that thought pop into your head, why don't they just fall down?
I mean, it's a great question, right? You're staring up at this incredible glittering canvas, and it's a totally logical thing to ask. What's holding them all in place? You might think, well, are they just little lights? Maybe they're, I don't know, pinned to some big black curtain up there. And honestly, that kind of makes sense when you're just looking at it with your own two eyes. Or, hey, maybe it's like what some ancient astronomers thought, that they're all just stuck to this giant celestial dome that spins around us. It's a really beautiful, neat, and tidy picture, for sure. But the actual reality, oh, it's so much more dynamic, so much bigger, and honestly, way more incredible than any of those early ideas. Okay, so let's get into it. Our first big reveal is all about stars being suns from far away. And this is the part where we've got to completely change how we think about what a star even is. So check this out. It's kind of the first mind-bending idea we need to tackle. What we see and what's actually out there are two completely different things. We see this tiny, peaceful dot of light, but in reality, it's a massive, violent, burning ball of gas. Yeah, just let that sink in for a second. Pretty much every single one of those little pinpricks of light you see in the sky is a sun, a huge, colossal nuclear furnace, and a lot of them are way bigger and hotter than our own sun. So that obviously leads to the next big question, right? If they're all these giant, blazing suns, why do they look so tiny? Well, the answer comes down to one simple but seriously mind-bending concept. And that concept is just distance. The answer is sheer, unbelievable, mind-boggling distance. They're not actually small at all. They're just so far away, farther than our brains can really even wrap themselves around. Let me try and put this in perspective for you. The absolute closest star system to us, Proxima Centauri, is 4.2 light years away. That means the light we see from it tonight took over 4 years just to get here. And get this, if you jumped on our fastest spacecraft to go there, that trip would take you almost 80,000 years.
Wow.
All right, on to the next major piece of the puzzle. In space, there's no down. And to really get this, we have to kind of throw out all our normal Earth-based rules and start thinking about the physics of the whole cosmos. Think about it. Here on Earth, gravity is super simple. It's got a clear direction. You drop your keys, they fall down, toward the center of the planet. Easy peasy. But once you get out there into the vacuum of space, those ideas just become, well, meaningless. There is no universal up or cosmic down. There's just no floor for anything to fall onto. So, instead of falling down, what stars and planets are really doing is constantly falling around each other. And that is what we call an orbit. It's basically a continuous, stable fall where something's forward speed perfectly balances out the pull of gravity. It's this incredible cosmic balancing act. You've got gravity, which is always trying to pull things in, and then you have the object's own speed, its velocity, trying to fling it forward in a straight line. And the result of this massive cosmic tug of war? A nice, stable orbit. Okay, but this brings up a really obvious question, doesn't it? If stars don't fall, then what on earth are those falling stars we're always told to wish on? Well, let's bust that myth right now. You see, what we all romantically call a shooting star, well, to scientists, it's just a meteor. And here's the kicker. A shooting star has absolutely nothing, and I mean nothing, to do with an actual star like our sun. It is not some distant sun taking a nosedive through the galaxy. The truth is, they're almost always just tiny bits of space junk, little pieces of dust and rock, a lot of them no bigger than a grain of sand. And they create that spectacular streak of light because they burn up from the insane friction when they hit Earth's atmosphere. Okay, so now we get to the final piece of this puzzle. And honestly, this one's the most mind-blowing of all. We're going to talk about seeing through time. Because all those stars are so many light years away, the light that's hitting your eyes tonight, it's not new, it's ancient. That light left its star a very long time ago. What does that mean? It means looking up at the night sky is exactly like looking into a time machine. The light from some of those stars started its journey to you before humans even built cities. You are literally seeing ghosts of light from the distant past. And that brings us all the way back to our original question. Stars don't fall down because they aren't really above us, stuck to some flat ceiling. No, they're all around us, suspended in this endless three-dimensional fabric of the universe. And every single one is held in a perfect cosmic dance by gravity and motion. So that really leaves us with one final, kind of awe-inspiring thought, doesn't it? If every single point of light up there is a message from the past, what other secrets are hiding in that light, just waiting for us to figure out how to read them?